Hello, my name is Martin Jenkner. I'm head of cybersecurity at Moxa Europe, and I will introduce you IEC-62443, which is a cybersecurity standard for OT. IEC-62443 is actually targeting industrial automation and control systems, and so it makes a difference between consumer type cybersecurity standards as well as enterprise-oriented cybersecurity standards. It covers three areas: people, technology, and processes, and it's of course different from other cybersecurity standards. So how is it different? Comparing cybersecurity standards is not easy, but if you have two dimensions, you can sort them in and see how different they are without understanding every little detail. One dimension is who is affected by the standard. And so there is a dimension that goes towards details for manufacturers as well as details of operation. This is basically the line of the value chain that we will see later. However, the other dimension is the classical challenge between details and coverage. Now let's start sorting in standards. ISO 27000, a very important standard for IT, is more on the side of a wide coverage as well as details of operation. It does not cover too many details for manufacturers and makes quite of a difference to another standard which is relevant for the marine market. Now let's have other standards in here as well, as NERC and specifically power standards, and all of those standards have their focus either on the detail side or on the coverage side, on the manufacturer side or on the asset owner side. One standard has a broader coverage, and that's IEC 62443, and one of its strengths is indeed the good coverage of all the stakeholders of the value chain. So we stick to the horizontal axis because this is the axis of the stakeholders, the axis of the value chain. And IEC 62443 defines three different players: product suppliers, system integrators, and asset owners. And so they also say quite clearly what is the task of each of these stakeholders. Product suppliers, for example, have to first create a secure product development environment in order to create secure products. These products have to be configured properly by system integrators who provide subsystems and put them together to the overall industrial automation and control system, which is finally operated by the asset owner. Not a surprise, IEC 62443 provides three chapters plus one general chapter to define exactly what those people have to do. In this presentation, we look into chapter number 4 and specifically the subchapter -4-1, which is important for product suppliers in order to ensure the secure development of products. So, what is -4-1 about? And the strategy behind -4-1 is a so-called defense in depth strategy, which consists of two rings. An outer ring, which contains 3 out of 8 practices. This is the security management, security defect management, and security update management. In the inner ring, which is repeated iteratively over time, starting from specific requirements, ending up in security guidelines. This is a ring that has to be run again and again, increasing the maturity of the secure development lifecycle. Let's look into an example to show what that means, and we look now into practice number 6, the security defect management. Practice number 6 contains 6 requirements called DM1 to DM6, and I'll share with you how Moxa implemented these 6 requirements. Let's start with, of course, DM1, which is about analyzing and tracking any kind of potential vulnerability, and this is defining one of the first of our 4 phases of Moxa's cybersecurity process. So we create a lot of awareness. We look into which product is affected by a potential vulnerability. We work very closely with ICS CERT, with third-party researchers, but even more, we enjoy working together with our customers. Once we have become aware about vulnerabilities, we kick in the second phase, which is about investigating which of our 2,500 products is affected by a vulnerability. General vulnerabilities, as in Ripple 20 or Shell Shock, made us spend quite a while to figure out which product has been affected. So we analyze which product is affected, the severity of it, and of course the impact. That leads finally to the action phase, where we address DM4, which says we have to tell our customers what to do. Sometimes this can be just disabling a functionality, but in best case, of course, we provide a patch at a certain point in time. And this is what we do in phase number 3, the action phase. And all these things finally end in phase number 4, where DM5 says that you better inform the public about this, and that's our publication phase. All these 4 steps have to be done very quickly. We are proud that when some years ago Shell Shock hit the industry, we did this within 2 weeks. So we fulfill the requirement DM2, doing this in a timely manner. And in order to do so, yes, of course, we fulfill DM number 6, which says we have a team and management process in place to ensure that this will happen anytime a vulnerability has been found. So what's the result? The result is a mature process that ends up in a very simple RSS feed that you can subscribe to. Just check the QR code or type in feed and the following part of the link, and your RSS client will automatically subscribe to our security advisories. So this was an example on how we managed to become IEC 62443-4-1 certified. Overall, we completed 8 practices, providing answers for 47 requirements. And in May 2020, we were finally certified as a secure product developer in the industrial automation and control space. Thank you.